I'm afraid I have some bad news for you. And at first it might make you sad, but at the end, it might make you happy. Now I'm going to ask you to keep an open mind about some of these things I'm going to introduce, because some of the convention that I'm going to be talking about is, well, that these are the same sum, but they're a little different, because I would like to introduce the idea that maybe if we can read this a little bit differently, that something like this will make more sense. Let me show you. I'm going to tie those in. I'm going to tie in how to read this into how to read this, so that no longer is this notation confusing. The only thing that will be left that's confusing are some multiplication facts. So let's get to it. Let's talk about, well, 3 times 5, and the difference between 3 times 5 and 5 times 3. Now, because of the commutative property of multiplication, of course, they both equal 15, right? But this 3 is 1, 2, 3, and this 5 says that I've got 5 groups of those 3. So I've got 3, and then another 3, and another 3, and 5 of them. Oh, said the number 5, wrote the number 5, excuse me. So we got 1, 2, 3, 4, 5 threes, all adding. Multiplication is repeated addition, and addition is repeated counting. We could break these down and all into ones and whatever, but that's not going to really serve our purpose here. Whereas this is 5, right? 1, 2, 3, 4, 5, and we have 3 of them, so this is 5 plus 5 plus 5, there's 3. Both equal 15, of course, no big deal, right? But let's talk about now multiplication with a fraction. So let's take our sum, 15, right? And let's multiply that by 1/5. And let's talk about what this fraction means, okay? Now let's talk about what it means, like, further than, past maybe like a 5th grade level. What this is really saying, this is saying, look, what number, multiplication is repeated addition, right? So what number added to itself 5 times equals 15? That's what this is saying. So this 5 right here is what number added to itself 5 times equals 15. And of course we know that that would of course be 3, right? So there's the first step, second step, third, fourth, and 5th. So first, second, third, fourth, and 5th. Okay, do you see where we're going with this? Hope so. Now this 1 right here is saying, hey, what's the first of the 5 steps? So this equals 3. And of course that makes sense, right? Because 5, the way we're taught it, 5 goes into 15 3 times. 3 times 1 is 3. And now though, make it a 4. This is the 4th step. It's 12. And that works because 5 goes into 15 3 times. 3 times 4. 12, right? Or I could make this a 2/5 instead. So I could do 15 times 2/5. And the second step right here is 6. Do you see? 5 goes into 15 3 times. 3 times 2 is 6. All right. What's all the fuss? Why we spend, 3 minutes talking about how to multiply whole numbers and fractions when they're reducible? Well, here, we'll get to it right now. Now, 3 times 5 again is 3 plus 3 plus 3 plus 3 plus 3. And it goes 3, 6, 9, 12, and 15, right? Now, this is the number that's been repeatedly added, and that's how many times. Exponents, repeated multiplication. This is the number that's being multiplied that many times. So it's 3 times 3 times 3 times 3 times 3. Do you see? And of course that would be 3. And 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3, 243. There are 5 of them there, you see? That's 5 steps of multiplication by 3, and we end up at 243. See? Step 1, 2, 3, 4, and 5. Okay, well, big deal, right? Multiplication, repeated multiplication with exponents, that's not confusing. But what is confusing is this. 243, right, to the, say, 3/5 power. Well, do you remember how 15 times 3/5 was asking what number being added with itself 5 times equals 15, and what's the third step? 1, 2, 3 would be 9. Well, this is the same thing, except instead of adding, it's multiplying. what number, this right here, this 5 says what number times itself 5 times equals 243. Well, that's 3, right? And we're looking for the third step, so it's 27. That's how it works. That's what that means. That's how that ties in to this. That's how multiplication repeated is, or that's how exponents are repeated multiplication, and multiplication is repeated addition. And the notation is really similar. You see, 3 times 5, this is repeated addition, and then the superscript is what it's called, means that we now are talking about, well, repeated multiplication. And there we go. Now, the tricky thing about this, when you think about it this way, well, it's no longer the notation, but that notation, that meaning that you can see in the notation is gone when we look at something like that. Why do we use that? That must be some like really old way of writing it, and this is much more efficient, it's cleaner, it's easy to understand. I can make the connection between, well, this written expression and this written expression. But from here to here, it's like totally different math. I don't get it. Well, this is better. Now, the thing about these rational exponents is actually that it's sometimes hard to know what times itself 6 times equals 729. We're not familiar with those math facts, but it's really not that bad, you see? Now, check this out. Turns out that 9 times 9 is 81 times 9, 729. Each of those 9s is 2 3s, yeah? So that 9 is 2 3s, this 9 is 2 3s, and this 9 over here, you guessed it, 2 3s. So 3 to the 6th, of course, equals 9 to the 3rd, because this is 3 squared. Anyway, without getting into that too much, here's the basic fact. Okay, here's the fact that if we know this fact, these are easy to handle. 729 equals 3 to the 6th, and 729 is also equal to 9 to the 3rd. Those are true, okay? If you don't understand how to manipulate the two, it doesn't really matter, but we can answer these two questions really easily. We can simplify these two things really easily by looking at this 6 and saying, this is saying what number has been multiplied by itself 6 times and has arrived at 729. Well, that's 3, 9, 27, 81, 243, and 729. That's 1, 2, 3, 4, 5, and 6 steps. Do you see? And this is asking us for, hey, what is the 5th step? Well, that's 243. Do you see? If you were familiar with these numbers, just vaguely familiar, it's really easy to figure this out. However, when I see this, that's confusing me. Now, I can translate them back and forth because they do mean the same thing, but unfortunately, we teach kids this first. We learn this. We don't learn what this means in this fashion, and I think that should change. Let's look at this last one again right here, this 729 to the 2/3. 729 to the 2/3 power. Now again, this 3 is saying, well, what times itself 3 times is 729. So 9 times 9 is 81. 81 times 9 is 729. So that's the number. 9 is the number times itself 3 times. It equals 729. The second step, 81. Let's look at one more example. Let's say, I'm going to make up one that's kind of easy, 3,125. Now, I do believe that that's 5 to the 5th. Let's find out. 5 times 5 is 25, times 5 is 125, times 5 is 625, and then, yes, 3125. So that's 1, 2, 3, 4, 5 steps. So 3125, you might see something like this. What is 3125 to the 2/5 power? Do you see? This fraction means it's asking like what times itself 5 times equals this, and what's the second step? 25. That's it. So anyway, my whole point was that I don't like this notation. This notation is ugly. This notation means something. That makes sense to me. I never thought about it that way until just recently. Anyway, if you're a math teacher, try teaching it like this. I tried it today with some sophomores, and they were blown away. They were actually a little upset that I didn't show them this before. They were upset that they were taught this way and then taught to translate. Whereas instead, if they were taught this first and then just taught to translate, it's really easy. So anyway, my name is Philip Brown. I hope this has been helpful. If it has, you could click like and subscribe and, well, maybe share it with some other people. Anyway, I hope you have a good day.